Okay, so today is September 28th, 2012. I'm here with my math research class, Stuyvesant High School, just to have for posterity. Anyone wants to scream something out for a second, you can be permanently on YouTube. Or cough is good also. So let's start with these two questions. Don't be nervous. I don't care. I'm famous. You're famous now. This thing doesn't have to be perfection, so don't get nervous that this is recording right now. But what is the answer? What's the multiple of 3? That's one more than a multiple of Carolyn? 45 is there a smaller one? 12 is even smaller. So it doesn't say to find the smallest one, so 45 is also. It just asks for any of them. But as far as the smallest one goes, I'll just write down that 4 times 3 is 12, which is 1 times 11 plus 1. That's your smallest one. So how about that? How about for number 2? What's the smallest multiple? Let me go with Stephanie. It is 22. 2 times 11 is 22, which is 7 times 3 plus 1. That's going to be an important step of doing the Chinese remainder theorem. The idea of finding a number, a multiple of one number is one more than a multiple of another number. And I'll show you why that works. Here's a Chinese remainder theorem question that has 2 equations instead of the 3 that we're building up to. So the question looks like this. Find smallest x so that when you divide x by 3, you get remainder 2. That's this notation. But if you divide x instead by 11, you get this number. So there's our question. Now you might come up with it just by messing around with numbers. Mohammed, I saw your hand went up. Messing around with numbers? Oh, okay. It's not a very large number. Take a minute to just... Hey, Angela, you got it already? Well, 28 divided by 3 is... 28, does that one work? 28 divided by 11, that gives you remainder 6. But 28 divided by 3, 27, remainder 1. Jonathan? 17 seems to be the smallest answer. Answer is 17, and it's true that 17, when you mod it by 3, meaning divide by 3 and take the remainder, you do get 2. And 17 mod 11, 17 divided by 11 is 1, remainder 6. So it does work. But now I want to show you a process. What if you couldn't figure it out by messing around with numbers? I'm going to show you a process. And what's great about this process is that it can be generalized to work for when there's 3 equations and the numbers are big, or 4 equations, or any number of equations. So this process can be generalized. This is what we do a lot in math. We learn how to do sort of an easy question in a hard way, because that hard way is going to be flexible and allow me to answer much harder questions later on down the road. So listen carefully. Here's how the process works. First of all, step 1 is going to be what you just did in the do now. Find, in this case, smallest multiple of 3. That is one more than multiple of 11. And that's what we did in the do now. It ended up being 12, which I'm going to write as 4 times 3. That's our first step. the 3 and the 11 are the two things that you're going to be dividing by. Step 2 is to do the other way around. Find smallest. Step 2, thanks. How about this? There's a little eraser on there. People always love that. They're surprised. Step 2. This is a good computer. iPads you can't really write on too well. This is a IBM Lenovo tablet. It's really good for writing. Find the smallest multiple. It's not an advertisement, but if they want to send me a free one because they see this video, I'll take it. Find the smallest multiple of 11. That is one more than a multiple of 3. In this case, it was 22, which was 7. Sorry, which was 2 times 11. And those are the first 2 steps of this problem. Finding a multiple of one thing that's one more than a multiple of the other, and a multiple of the other thing that's one more than a multiple of the first thing. That itself can be complicated, but for now, we do it by trial and error, yes?
Also, this can only be used for 2 equations?
We're going to generalize it on the next class, but for today, it can only be used for 2 equations. But 2 equations is not that easy. So it's going to be good to have a method for that. But yes, it's going to be, the method for 3 equations isn't that different. It's a little bit more complicated. Now here's something to think about. We have these 2 numbers. Here's a question I want everyone to think about now. What would happen if you divided 4 times 3 plus 2 times 11? If you were to divide it by 3, what would you get as the remainder? Or if you were to divide it by 11, what would you get as? So the sum of these 2 things, what should the remainder be when I divide? David?
1.
For which one?
Both.
For both. That's a very important observation. You might remember from yesterday, if you divide this top one by 3, the 4 times 3 does not affect the remainder because 4 times 3 is 3 goes into it. So all that matters is what the remainder is when you divide 2 times 11 by 3, but we've already established that 2 times 11 was the special number that when you divide by 3 you get remainder 1. But on the other hand, when I take this bottom one and divide by 11, the 2 times 11 doesn't really impact the remainder. So the whole remainder is what you get when you divide 4 times 3 by 11. But we've already established up here that 4 times 3 is the special number that when you divide by 11 you get remainder 1. So the sum of these things is the number 1. But remember my question. I don't want remainder 1 when I divide by 3 and remainder 1 when I divide by 11. If that was the question, I'd be finished. Instead, they asked, I want to get remainder 2 when I divide by 3 and remainder 6 when I divide by 11. Anyone have a thought of how I can alter this so that that might happen? Jeffrey.
You multiply the remainder that you want to find. You multiply that remainder by the corresponding one. So you want to find the remainder of 2 when you're dividing by 3.
Yes.
So you multiply 2 times 4 times 3, and you're finding a remainder of 6 when you're dividing by 11. So you do 6 times 2 times 11.
I like what you said. There's a slight inaccuracy, but you have the exact right idea. Jeffrey's saying that we're somehow going to take these 2 remainders, the 2 and the 6 that I want, and insert them in here. But Jeffrey, if you put...
Oh, it's the other way.
It is the other way around, and that's a little confusing. But let's take a look why this works. So down here, I'm going to write 4 times 3 plus 2 times 11. I want there to be a remainder 2 when I divide by 3. So I put the 2 here. If I put anything here, it's not going to change what happens when I divide by 3, because that has a 3 in it. And I put the 6 over here. Now I'll just give you just a second to sort of look at this and convince ourselves why this works. If I take this thing and I divide it by, and I mod it by 3, this thing will not affect the remainder. But this thing was the special thing I figured out in step 1 that would give me remainder 1 when I divide by 3. So by sticking the remainder I want, by multiplying that by this other number, I'm going to get what I want as the answer. But on the other hand, when I divide this thing by 11, this thing's not going to impact the remainder. Remember, 4 times 3 was the special number that when you divide by 11, you get remainder 1. So by putting a 6 in front of there, it's going to be remainder 6. And this is, a bit confusing. If I turned it into a formula with A's and B's, it would be pretty confusing. But I guess the thing that you'll remember is that the thing that's next to remainder 3 is going to go, the remainder I want when I divide it by 3 is going to go next to the thing with the 11 in it. Incidentally, 6 times 4 times 3 happens to equal 72. And 2 times 2 times 11 happens to equal 44. And the sum of those two things is 116. So 116 is a number that satisfies the two equations. If you divide it by 3, you do get remainder 2. If you divide by 11, you do get remainder 6. Yes?
Would that be the lowest?
It's not the smallest. So now here's the sneaky way of getting the smallest. I see. So how many have your hand? Is your hand up for that, or we want a smaller answer, a smaller number that satisfies the two properties. Anyone have a thought of a sneaky way of getting? And it doesn't have to be the smallest, but a smaller one that also will work. Yes. If you divide by 2, you might change the remainders. So dividing by 2 may not get me there, but I could subtract something so that the remainder when I divide by 3 won't change, and the remainder when I divide by 11 won't change. Yes?
You're subtracted by 33.
That's correct. If I were to subtract 33 from this thing, which I'm going to write as 3 times 11, I would get a smaller answer, which would be 83, which also, yes?
Why, like I see this model, like model times mod 3, which gives 33 y greater.
Well, 33, if I were to try to take this number and do the remainder when I divide by 3, not only would this thing not be relevant, but this one also wouldn't change the remainder. So it doesn't change the answer at all. So dividing in this case by 33 gets me another answer. That works. But 83 is not the smallest answer that works. How can I get a smaller one? Yes? Huh? Subtract 33 again. In other words, take away 2 times 33, which is 66. And now I've got a smaller answer, which is 50. How do I polish this question off, Mohammed?
So last time you minus 33 again,
That's right. So if I do 3 times 3 times 11, which is 99, I get 17, which is the answer. So now, when you look at this expression here, this kind of fancy looking expression, I hope you can see all the individual components of it. The fact that this thing, this minus at the end, its purpose is just to get me a smaller answer that works. In here, we have the answers from part 1 and part 2. I can't remember which part was which. Let's see. 12. Okay, so the 4 times 3. So this thing came from step 1. This thing came from step 2. These things are the 2 remainders that I want to get. That could be confusing. I could see someone getting it backwards. But the trick is, you saw Jeffrey almost fell for it, that he put the 3 with the remainder from 3, but the 3 goes with the remainder for 3 goes with the 11, and the remainder for the 11 goes with the 3. You can just remember it's sort of backwards. This thing's just an adjustment factor. By the way, this whole thing is this part here is step 3 of the process, creating this number. And this is step 4, is the adjustment. Anyone know how I might have jumped straight to knowing that this needs to be a 3 here in front of everything, rather than keep subtracting away 33? Yes?
3.
What's that?
Because there's an odd 3 at that.
Oh, no, it could have been a bigger number. It could have been 4 or 5. It is possible that it was bigger. But how could I have known right away to stick a 3 in front? Yes?
Because the biggest multiple of 33 that fits into 160.
That's right. Divide the product into the original sum, which was 116, and it goes in 3 times. So that's how many of them you're going to be able to take out of there. So that's the process. Now I'm going to give you a chance to do a question using this same process, and I have a sheet with 8 questions on it. But let me put up question number 2. It's a pretty cool process. Here's a question. I'll give out the worksheet also. But I want you to try to go through the 4-step process yourself now. Okay, and everyone take a few minutes to do this. You can work with your neighbors to make sure that you're following the four steps. Yes, sir. She's getting to use the awesome tablet computer. First, she found the multiple of 5. That's 1 more than a multiple of 7. There's the multiple of 7. That's 1 more than a multiple of 5. If she were to add those 2 things together and mod them by the 2 numbers, in this case, she'd get 1 for both of them. Yeah, you could put more. Yeah, some people would maybe put more parentheses, but it's okay. So she wants to have remainder 3, which she divides by 7. So she puts the 3 in front of the 3 times 5. Wants remainder 2 when you divide by 5. Oh, here's the adjustment. We'll talk about that afterwards. You know, Stephanie, you can do the adjustment after, like, after you show what the numbers become.
Okay.
So here's her answer, initial answer. 87. Now 87 works, but she can get a smaller answer. How's that? By taking away 70. Okay, everyone, give her a hand. Thanks, Tiffany. On a test, you won't have to write, for instance, this step here isn't needed for the test, but it's good for our purposes now just to get a feel for why this works. I really like this expression. Remember the homework, the assignment we did yesterday? The expressions resembles this. And I hope that when you look at this now, this long expression, you can see all the little pieces and why the Chinese remainder theorem process works. Now, David asked an excellent question, which was, what if I don't know this number? You know, what if the numbers are too big? Well, on Monday, I will show you how you can come up with that number. And a hint is that it utilizes something that we've already learned. So now I'm going to give you time to work on questions 2 through 8.
Will this be our homework?
This is going to be the next assignment. Yeah, this is our classwork, and it will move into homework also.